Hi everyone, this is Advanced Statistics for the Social Sciences. In the fourth and final lecture on one-factor ANOVA, we will discuss how to proceed with further significance testing and what types of tests are available to us once we have determined a significant overall F-test or a significant overall model effect of the predictor on the outcome. So this is essentially telling us, this slide shows us the different conclusions we can make when we are significance testing with ANOVA. So we're working with p-values, and we know by now that if a p-value is greater than 0.05, we conclude that the overall significance test is not significant. This is telling us that the explanatory variable, the predictor, has no effect. Or alternatively, we could conclude that there are no significant differences among any of the groups. So if p is less than 0.05, this is a significant test, and this is essentially telling us from the F-test that the predictor does have some effect on the outcome, such that at least two of the groups have significant differences. So in our example, the ANOVA is statistically significant because the p-value associated with our calculated F-test was 0.015, and that's less than 0.05. The F statistic that was calculated from the mean squares was 0.606, and so the way that we would interpret this is that an F statistic of 6.06 is unlikely if the groups are truly identical in the full population. So this F statistic is unlikely if the groups are coming from the same population and we haven't sort of created these new populations by assigning these different quit methods. So therefore, we refute the null hypothesis and we conclude that the quit methods do define distinct populations. That is, the quit methods define different groups that have different means, different average smoking intensity, such that at least two of the groups have significantly different smoking intensity from each other. But we don't know which of the groups are differing at this point because we have more than two groups. So we can't just conclude that there were group differences. We have to know how the groups differed from one another. The F statistic is non-specific and it doesn't give us that information. It only evaluates the overall effect of the predictor on the outcome. So it tells us there are some group differences, but not which ones. So in order to determine which groups differ, we have to examine the specific model components, which means running some follow-up tests. So once we have a significant F-test, we conduct some additional tests. And the first thing that we do, this is that flow chart that's showing us how to proceed once we've assessed our overall F statistic. If the overall F statistic is not significant, the p-value associated is greater than 0.05, then we stop and we conclude that there were no significant differences among any of the groups. But if the p-value associated with our F-test is less than 0.05, then we move into some specific group comparisons. There are two big types of follow-up tests that we hear about. So there are planned contrasts, and planned contrasts are targeted comparisons where we compare specific pairs of groups, but not necessarily all of the pairs of groups. This is when we have some sort of a priori hypothesis about which groups might differ. Now, if we don't have hypotheses about how the groups are going to differ, we would do post hoc comparisons. And post hoc comparisons typically involve every possible two-group comparison. So we just take all of the pairs of groups and compare them to each other to see which ones are significantly different. And in order to compare the pairs of groups, we use modified independent samples t-tests. So basically, we use independent samples t-tests when we have just two groups and we're interested in looking at the group differences. We're basically using these t-tests as post hoc tests after we've already run an overall ANOVA model. So post hoc comparisons, this is what post hoc comparisons and planned contrasts might look like if we were interested in doing each type of comparison or each type of follow-up test with our smoking example. So if we look at this figure on the left, this would be an example of what the post hoc comparisons would look like. We would be comparing all of the pairs of groups. And here we've got three groups, and so we've got 3 pairs. We would look at financial versus nicotine therapy, the financial incentive versus the cold turkey group, and then the nicotine therapy versus the cold turkey group. And so here we don't really have a hypothesis. We're just kind of throwing in all of these comparisons to see what sticks, so that we can just rely on the results of these post hoc comparisons to tell us which groups are significantly different. Now, planned contrasts are a little bit different because we may have some hypotheses about which groups we think will differ significantly, or we may have specific pairs of interest that we want to compare. An example, using this example, this is a pretty good example for thinking about planned contrasts, because in this example, we have one, what's essentially control group. We have one group that's cold turkey. They're getting no help, no therapy at all, no incentives for quitting smoking. And then we have a financial incentive group and a nicotine therapy group. So they are receiving some sort of assistance, some sort of aid in quitting smoking. Now, we may think one might be more effective than the other, financial incentive versus nicotine, but in all likelihood, probably both are going to be somewhat more effective in reducing smoking intensity than the group with no help at all. So we may not even be interested in comparing the financial incentive and nicotine therapy group. So if we look at this figure on the right, we see in planned contrasts, there's an NA plot next to financial versus nicotine, because we think both of these groups will be more effective in, reducing smoking intensity. We don't need to compare them. Really, all we're interested in is comparing each of those groups to the no help group. So those would be our planned contrasts. We would compare the financial incentive group to the no help group, because we think the financial incentive will reduce smoking intensity more than the no help group. And then we will do a planned contrast of the nicotine versus the no help group, again with the same hypothesis that the nicotine therapy group will reduce smoking intensity more than the cold turkey group. So this is what the SPSS output would look like from doing multiple comparisons. So this would be the post hoc comparisons route, where we compare all of the different mean differences. So you can see that we have a couple of columns here on the left. We've got quit method, quit method 1 and then quit method 2. So we can see in those first 2 rows, looking at the first 2 columns, that there is the no help group as compared to the financial group, and the no help group as compared to the nicotine group. And the actual mean difference is in raw units of smoking intensity. So we can see that, and again, this is the mean differences across groups. And then we can see that there are asterisks next to some of those numbers, and the asterisk indicates that mean difference is significant with p less than 0.05 according to the t-test that's been calculated on that statistic. So you know that, hopefully by now, you know that a t-test is a mean difference divided by a standard error that gives us some associated t-value and an associated p-value that tells us significance. So we've got this column that's highlighted in purple that gives us the mean differences in the metric of smoking intensity. Next to that is the standard error. And then the t-value is not reported, but the significance is. So that's the column to the right of the standard error. And we can see that any mean difference in the purple box that has a significance value of less than 0.05 has an asterisk next to it. And that's telling us that that's a significant group difference. So if we go through and look at these, we see that the difference between the no help and the financial group was significant, and the no help and the nicotine therapy group was also significant. And as we had talked about with the sort of logic of planned contrasts in this example, it doesn't look like there was a significant difference between the financial incentive and the nicotine therapy groups. They both were effective in reducing smoking intensity, and there's no real difference between them, no significant difference between them. Okay. So based on these multiple comparisons, these follow-up tests, we have concluded already that the overall model is significant and there are some group differences. But now with the multiple comparisons, we can confirm that the financial incentive strategy and the nicotine replacement therapy strategy, those conditions do not differ, but both groups are significantly better than the cold turkey condition in reducing smoking intensity. That is, they have lower means on smoking intensity than the cold turkey condition. And so we can conclude that these specific components of the model, right, these group differences were what was driving that overall significant F-test from the Way ANOVA. This is what an APA-style table would look like if we were to report the means and standard deviations. Typically, we are going to report the actual analysis results in text, and I will show that next. But if we wanted to create an APA-style table, what we would do would be to separate out the means by group and report the means by group, the standard deviations within each group, and then the sample size within each group. So note that we have 15 overall participants in the example and 5 per group, and that's the N that's being reported corresponding to each group in this table. Lastly, we have this APA-style results summary table. And I will post these slides on Blackboard for you as well, of sort of overall APA-style result summaries from all of the different analyses. But for ANOVA, this is how we would report it. It's similar to how we would report regression. So we would say, we performed a one-factor ANOVA analysis to assess differences among the 3 smoking cessation strategies. Table 1 gives the means and standard deviations for each condition. The analysis revealed statistically significant differences among the group means, reporting the F value as it's shown here and the P value. Further, the R-square effect size indicated that quit method explained approximately 50% of the variability in smoking intensity, which is a large effect by conventional standards. Now, in addition to this overall APA-style result summary of just the overall F model, you can go in depth, a little more in depth here after reporting the overall F test and say that the follow-up tests indicated that the driving mean differences were the mean difference between the financial incentive condition and no help at all and the nicotine therapy condition and no help at all. And that would be what you would write sort of in the next paragraph after, is going into the examining the specific model components to see what was driving the significant F test. This concludes the 4th lecture on one-factor ANOVA. And next up, we will talk about ANOVA with more than one factor. So factorial ANOVA or 2-3 factor ANOVA.